As the arrow indicates, this is our y value. If a day was a holiday like March 1st, we use the nearest trading day instead. Follow the n+1 rule, which means we need 5 data points since the degree is 4. As you can see, we highlight the 5 nearest local points from S0 to S4. Now, looking at this Px4 formula, we can see that the function values from f at 0 until f at 4 are actually the y values we already know. So our main task now is to find the values for the basis polynomial starting with L0. This from our table that we highlight here. But first, let's determine our x value. We are approximating for June 5th and our nearest previous grid point was June 1st, which is day 31. We simply add the 4-day difference. This gives us x equal to 35 as our target point. Now, look at the L0 formula. We substitute our x value, which is 35, and then we plug in at 0 until x4 that we select from the table. By calculating this fraction, we get the specific weight for our first point. Once we have all our L values, we plug them back into the main quartic Lagrange equation. We multiply each basis polynomial by its respective volume. We compare our approximate result with the exact. We select the last 5 points from our table, which are x7 until x11. Then we relabel this point as x0 until x4. Just like our previous calculation, we apply the same step for this new set of data. After substituting this value into the main equation, we get our second approximate.
For task 2, question A1, I've made a graph for the two companies of the bankings, and then I used the X for the month number, which is 1 until 12, based on the months, and then FX based on the stock price from the graph. And then I've structured the table based on X, FX, first DD until 5th DD. For the first DD, I've used the first divided difference formula, and then the second DD column I've used for the second divided difference formula. And I continue until the 5th order. Next is for the question A2. I've used the Newton forward polynomial, which is the starting point x not equal to 1 for Maybank. I've used the formula, and then I've used the formula from the table from question A1. And then for the question A3, I've used the Newton backward polynomial for the bank CIMB start from the starting point x not 11. I've used the formula for the Newton backward, same idea, but the start is from the end of the table. For question B, I've used the least squares, which is the quadratic fit formula. I've used the formula y equal to a plus bx plus cx squared, and then I compute the matrix table, and I've created the table and find all the sums, and then solve for the 3 equations, which is a, b, and c. And for the final equation, I start the equation fx equals to a plus bx plus cx squared, and I've used that for the both companies.
Next, I will explain how I get the answer for task 3. For A, we need to write down the equation first, so then we spread it up, and the last will be y squared equal to 1 over b plus a over b multiplied with 1 over x squared. So we need to refer the transcendental function, here the transcendental function table. So it will be y equal to y squared, a not equal to 1 over b, a1 equal to a over b, x will be 1 over x squared. So we will need to do the table, so that will be easy to us to do the statistic. So here is the x and y old, and here is x and y new. So we need to put the value of x old and y old into the equation of x new and y new, so that will be put into the statistic solving. So T is the formula that we need to write down. Is the must to do. Then the value, and then next I will explain how I get the answer for all of this for the next video. How I get A0 and A1. First, we need to shift, reset, and 3. You see there we need to off the frequency here and going down, and 3 and off frequency, and then we click here and we search for this 6, and we choose linear because it's a linear question. So we need to add all of the numbers, and after we put all of the x new and y new, we need to click SC and then option and 2 to get the number of x, y, all of that. To get the answer for A0 and 1, we need to click to push AC and then option and 3, and here we get the answer for A0 and A1. So after I put the value, this is the last equation, the last answer, which is A0 equal to 0.999, A1 equal to 21001. So we need to search the value of A and B. So we use the transistor function formula. Then we'll get the B equal to 1001, A equal to 21003. So for part B, we need to search the value of y, so we will add the value of x 3.35 into the equation, and the last answer will be 108454. Now I will explain how I get the answer for task 4. For 1 Roman, the general question is fx equal to AO plus A1 s plus A2 bracket 1 over 2 3x squared minus 1. So 2 Roman, they insist the interval is minus 1 to 1. There is no linear transformation, so this is the equation. For part 2, we want to search the polynomial on the interval. So we as we can see here, this is degree 2, so we need to do a KO until the K2. So which is the last answer, 1.8415. For K1, the answer is 0. For K2, the answer is 16898. So after that we get all the answer, we need to put into the equation. So the last answer is 2.5347 x squared minus 0.9966. For part B, we want to find the polynomial on the interval which is from 0 to 2. So let's x equal to AT plus B. So we need to find A and B. This is the A and B. Next we have to multiply with 2 because it's degree 2. Then we need to do K equal to 0 until K into K equal to 2. So this is the last answer after we get all the answer for K, which is 2.7486 square minus 5.2397t plus 353s4. As we can see here, we didn't use the x, which is we use t, so we need to replace t into the x, so we need t equal to x minus 1. So we need to replace, and the last answer is 2.7486x squared minus 10.7369x plus 11.5241.